We will continue to study truth tables. In 3.4, we will directly focus on conditional and biconditional statements. In looking at this image, it says first conditional. If I study, comma, I will pass my exams. You can rewrite this as I will pass my exams if I study. So these two statements here are equivalent and just rewritten in a different way. So what you need to remember is if you are working with a conditional and if it doesn't look right to you, then rewrite it. So with regards to the truth value of a conditional statement, it states on here the conditional is false only when the antecedent is true and the consequent is false. What that means is that you will get a false result. Your final result will be false if the antecedent, the first part, the first statement is true and the consequent is false. That is the only time. So you can see on the second row here on this truth table that P is true, Q is false. You have your conditional. The result will give you false. Otherwise, the remaining options are all true. All right, our first challenge. It says construct a truth table for not Q, then not P. So we have a conditional. That's going to be the final column that we're looking for. Notice in the statement, we start out with a not Q. So we need to go find our not Q, and I'm going to fill this in on that truth table. And then we also need a not P. I'll put that in to that next column. And the final column will give me that original statement. If not Q, then not P. And let's focus on our truth table now. So if I want to get not Q, I need to look at my Q column so that I can do the opposite of it and get not Q, the negation. So this will make it false. I'm just doing the opposite truth value for the Q column. Next, I'm going to go and look at my P column, the truth values on the P column listed, and take the opposite of each one so that I have the negation of P. And that'll give me false, false, true, true. All right, lastly, we're doing our conditional. Remember on the conditional, it says if it starts with true and it points to a false, the outcome will be false. So if you take a look with the negation column of Q, negation of Q, look for your trues. I have two of them, and I have one of them that goes from a true to a false. This would be true to false. So that gives my result here as a false. The rest of my column will be true. And this is the truth table for the negation of Q implies the negation of P. Our next problem asks us to construct a truth table for, and notice we have the brackets, and it says P or Q in parentheses, and not P implies Q. Well, that's a busy problem. But remember, we're going to take this one at a time, starting as if we're doing order of operations. So what we can look at is, let's look at P or Q first. Then we'll go in, we'll just call this number 1, item to go do. Next, I'll go find the negation of P. Next, I'm going to find the conjunction. Then I'm going to do the conditional. So hopefully you can follow me. I'm looking at the symbols for each one. So first I said I need to find P or Q. After that, I need to find my negation of P. Next, I'm going to go for the conjunction. So I have P or Q and not P. So that is everything in front of the conditional arrow. And what I did is I added on another column here because I like to place what is going to be my consequent after the antecedent. So I'll just rewrite Q after that. Again, you can skip this part. This is just something that I like to do. And lastly, we're going to go with the original statement, which I will just squeeze in here. P or Q and not P, and arrow over to Q. All right, so that's our original statement that we're wanting to do the truth table for. So let's start with the very first column, P or Q. Remember on the or, there's a condition. It says that it is false when they are both false. So we're looking at the fact that both of these are false right here. That'll give me a false result here. Otherwise, it's always true. Next, we're going to look at, let me erase this part here. Next, we're going to take a look at rewriting the negation of P. All right, so in order to find the negation of P, what I need to do is focus on P. So the negation of P is going to be false, false, true, true. All right, now we're going to look at the next column and we're looking for the conjunction. This is and. So the conjunction, I'm looking at the first part of the statement here and the next part of the statement for that conjunction. All right, a conjunction says that the result is true when both items are true. This is the only time right here that you see a true and a true. So the result would be true. That's the only special condition for a conjunction. Everything else will be false. And next, I'm going to rewrite my Q column. Q is true, false, true, false. All right, so let me erase. Actually, I can just leave that like that. Our last column is the original statement. So I'm looking at this conditional right here. Remember the scenario for conditional. If we start with a true and we move to a false, the answer is false. And you can see that none of these, I have a false to true, a false to false, a true to true, or a false to false. So these are all coming out to be true. Once again, it is if you start with a true as the antecedent, the consequent is false, the result will be false. And that's the only condition on this conditional. Otherwise, all other situations will give you a true. So since this is all true, we have what's called a tautology. When the final column is all true, the statement is a tautology. Self-contradictions. I think this one is pretty self-explanatory, but let's go through that. It says if you have a column P and you list it as P is true or P is false, and you take the negation of P, the opposite truth values, when you do a conjunction of the two items, you will get false and false. So the answer is always false, and that's called a self-contradiction. Our next definition is of the biconditional statement. A biconditional is true. In other words, the outcome will be true only when, and it says that the component statements have the same truth values, meaning that if you have a true, remember it's biconditional, to another true, this will give you a true result. Or if you have false biconditional to false. This will give you a true result. The biconditional is true only when the component statements have the same truth value. All right, so that is the case for this first one, first row, and then the last row. Then you can see that the results are true for each one of those. Construct a truth table for the following statement. So we have, let me write this up a little bit. I have P or Q, biconditional, and in parentheses I have not Q implies P. So one of the first things that we need to take a look at is to see what you need. On the first one, P or Q, we can go ahead and find that. That's not going to be a problem. When you take a look at what's after the biconditional, we need to find this not Q so that we can go in and find conditional. And then lastly, we're going to do the biconditional part. I inserted an extra line here so that I could set it up the way that I have a preference to do. And again, it's up to you and how you want to set up your own truth table. When you're working on the math software, it is kind to you and it gives you exactly what you need to be looking at for each row. So on this one here, number one says I need to go find P or Q. And the second thing I need to go find is my not Q. And this is where I like to write a little rewrite. I'll just put P right back over here after the not Q. And I'm doing that so that those two columns will be in order when I look at this next condition. Not Q implies P. And then lastly, we will do the original statement. P or Q, biconditional, not Q implies P. All right, so let's get started on this. P or Q. Again, this is a disjunction or, and the condition for that is if they're both false, the answer is false. So once again, they're both false right here. That will give me a final result of false. All other case scenarios would be true. Next, I'm going to write not Q. Let me put this in a different color if I can. Not Q is going to be the opposite of Q. So this would be false, true, false, true. I'm then going to rewrite the P column. 2 trues, 2 falses. And now I'm going to go and focus in on my conditional. If not Q, then P. And we just learned that on a conditional, if it says true is the antecedent, it implies a false consequent, the answer will be false. So the only time I have that occurring is on this last case, true to a false. So this is the only option that will give me false. And then I'm going to write true for all other situations. Okay, and lastly, we have the biconditional. The biconditional says that if they have the same truth value, true to true, and a biconditional to false, then the answer will be true. So in this case here, I am now looking at this column right here. That's going to go in front of the biconditional symbol, and this column right here goes after the biconditional. So if they're both true, so I have on that first row a true, 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 and once again, a true. And if we read at the top, it says determine whether the statement is a tautology. So this is a tautology. We have worked a problem similar to this in the previous section, and it says determine the truth value for the following statement when P is false and Q is false. Now remember, there's two ways you can work this. You can do a truth table, or you can directly insert the truth value into the original statement. So if you were doing a truth table, what you could do is we would have our P column, our Q column. And again, what I'm doing is I'm focusing on this statement. And what I would need after my Q column would be a conditional, if P, then Q. And then lastly, it would be the original statement, the negation of the conditional, if P, then Q. And this is how you would set up your truth table. And I'll go ahead and work it out this time since I didn't work it out this way on the last problem we did that was similar. So remember, if you're looking at your truth values in this case, it said that P is false, and it gave you Q is false. Whoops. So you don't have to do both or all four different situations and cases. You can actually just focus in on what they provided for you. Next, you're going to look at the conditional. Remember, the conditional says if it has a true, implies a false, the answer is false. And we don't have that situation. We have a false to false. So this is going to give me a true statement. And lastly, we're going to have to do the negation of that conditional. So the opposite of the conditional would give you a false answer. So we're looking for an answer that's going to be false. That's one way to do it. All right, let's take a look at this statement one more time. It says the negation of if P, then Q. And this is how we worked it last time. Negation of, and what I'll do is insert those values. P is false, this is truth value, and Q is false. So if we have a false to false on a conditional, that will give me a true result. Then the negation of a true will result with a false. So either way, you will get this final answer of false.